Hello everybody. I'm Arjan. I'm a maintainer for NixOS, mostly working on systemd stuff. That's actually the fault of this conference. I was here in 2019 at the same location where I met a bunch of maintainers from NixOS, and they convinced me to start contributing. And now we're back in the same room where this happened, probably somewhere over there on some table. So it's nice to be back. So today we're talking about my home lab. I have a home lab at home, like a media server and a web server running my website. And one day I wanted to add monitoring and alerting to this. That ended up being an enormous rabbit hole where I reinvented my own cloud from scratch. And yeah, this is that story. But yeah, what I wanted to have is want to set up Prometheus to scrape all the nodes in my home lab and have like alerting rules to see if everything is up. And then send that to Alert Manager, which collects all these alerts and deduplicates them and then sends alerts to my phone. That was the end goal. And then, well, I was bored, so I made it very complicated. So. My home lab is written in NixOS, of course. In this talk, I'm not going to talk too much into how NixOS works or what it is, but more how I'm using it. NixOS is a declarative operating system where you can define everything that's running on your machine in like a config file format where you define what packages you install, what services you want to run. And there's also some deployment tools that allow you to define like a cluster of servers and define them at the same time. So we had that image of my home lab, and this is like a very succinct definition of that. I have a web server running Nginx, a media server running mini DLNA, so I can stream my movies to my TV, a metric server running Prometheus, an alert server running Alert Manager, and then the default section is settings that you set for all your nodes. So all my nodes need to run Prometheus node exporter, and they are in the home lab.internal networking domain. Here's the Prometheus config. So I set up some scrape configs that iterates over all the nodes in my network, and we scrape the node exporter endpoint. And that way Prometheus discovers all the nodes in my network and starts scraping them for metrics. And I have some alerting rules, just one that just checks if something is up or down. Then we have Alert Manager, so we configure my Prometheus server to forward alerts to the alert server. And so that's here. So this is defining the metric server has an Alert Manager config that says, okay, we send it to alert server.homelab.internal. And here's the config of my Alert Manager server, which collects the alerts and then sends them to this webhook, which sends a ping to my phone. Okay, that's all really cool. We have monitoring and alerting, but there are some problems with this setup that I was not satisfied with. First of all, I commit this to my Git repository, and anybody who has this webhook link can send alerts to my phone, which is not nice. You can go try that if you want. Also, anyone in my network can talk to the Alert Manager, not just Prometheus, so people can just make up alerts and wake me up. And anybody can also just look at all the metrics that my nodes expose, and I don't want that. Of course, my network is local, but if somebody is in my house, I don't want them to do that. So this is where the complicated stuff begins. Let's think about the webhook secret first, right? Okay, so we need to store this webhook URL somewhere secure, so I'm going to deploy OpenBow, where I can store all my secrets. So I create another node in my home lab starting up an OpenBOW server. Okay, super. So we can store the webhook URL in OpenBOW, and then Alert Manager can fetch it from OpenBOW on startup. Easy. We'll just add a little pre-start script to Alert Manager that logins to OpenBOW and then fetches the webhook URL and then uses that instead. So no more secrets, right? But now the question is, how do I talk to OpenBOW? I need some token to authenticate to OpenBOW. Yeah, so we just moved the goalpost to somewhere else, and we still have the same problem. So now Alert Manager needs a secret to authenticate to OpenBOW. Where do I get that secret from? Also, maybe we should encrypt traffic between OpenBOW and Alert Manager. Otherwise, people can just sniff the webhook secret and still get everything, right? So it doesn't really, we didn't really gain anything. We just created more problems. So at work, we use AWS. And there our turtle is very cloud-shaped, and AWS gives us all kinds of nice things, right? Like they have IAM roles, and every EC2 instance gets credentials that are managed by AWS that are automatically renewed, that allow you to talk to services in AWS, like AWS Secrets Manager. And similarly, if you have like a GitHub action, you can talk to Docker Hub or NPM using an ID token, or if you're in a Kubernetes cluster, you can use a service account to talk to other services. So yeah, in those cases, the problem is solved by the platform, but at home, I'm not running on AWS. So I need to somehow reinvent what they're doing from scratch. So yeah, I want to have cloud workload identity at home. And we have cloud workload identity at home, and there's this project called SPIFFE, which stands for Secure Production Identity Framework for Everyone, which is a set of standards to talk about workload identity. And they standardize on a thing called SVIDs, which are short-lived credentials exposed as X509 certificates. And they standardize some kind of workload identity API that allows you to fetch these SVIDs. Where the identity API gets these SVIDs from, that's the rest of the all that you have to draw yourself. But yeah, a SPIFFE ID is just a URI identifying some workload in your network. It's a free-form thing. You can choose whatever you want. But the important thing is that each of our workloads is going to have some unique name that we want to have a credential for. Yeah, and such a workload identity document for SPIFFE is just an X509 certificate, but a short-lived one. Like this one is valid for 1 hour, and it's valid for the Alert Manager workload. And we just fetch this from the workload identity API, and then the workload identity API gives us our secrets, and then things are solved. But yeah, so yeah, workload identity API is just some Unix domain socket or an IP address with some gRPC interface, and you ask it, what is my identity, and it gives you back a private key and a certificate. But yeah, we need to now have this workload identity API hosted somewhere, and it needs to mint secrets, so we moved the goalpost further one more step, right? So yeah, there's a reference implementation of this workload identity API called Spire. How this works is it serves this workload identity API over Unix domain sockets, and your services on your Linux server can authenticate automatically using their peer credentials to get a workload identity document from this API. And then your actual nodes attest their identity to the CA server using plugins. So they move the problem to somebody else again, right? And they have a few plugins for like Azure and AWS, which uses the mechanisms from those cloud providers. But they also provide some plugins that you can use in your home lab. So they have a plugin to do like Acme. So you do like an Acme challenge to get a certificate. And they also have a plugin to use TPMs to mint a workload identity. 1 second. Yeah, so the simplest plugin that you can install for Spire is the HTTP challenge one. And this is just it works the same as Let's Encrypt. Like my server, my alert manager comes up and it says to Spire server, hey, I want to have a certificate for alert manager. And then Spire server says, okay, you can have it. Or in this case, the secret server, the OpenBOW server. Okay, you can have it, but you have to serve this challenge on this well-known URI. And if you do that, then I'll give you a certificate. So yeah, the plan is we're going to install Spire server, run the Spire agent on all nodes, and set up this Acme challenge thing, and then reconfigure OpenBOW, Prometheus, Node Exporter, and Alert Manager to use these workload identity documents to authenticate to each other. So yeah, we can deploy another server in my home lab, so more complexity, but it's okay, called Spire server. And then on all the nodes in our cluster, we run the Spire agent and we configure it to do the HTTP challenge. Yeah, and you can see that there's both workload attestation and node attestation. And the idea in this case is the workload attester plugin for systemd means that if you have a systemd service running and it talks to this workload API, then the workload API knows, oh, it's this systemd service talking to me. I will give this identity. So, for example, if the Nginx systemd service talks to the workload identity API, it doesn't get a certificate. But if the OpenBOW systemd service talks to the identity API, it gets a certificate back for OpenBOW. Yeah, and you configure this using entries. So you specify like, okay, the secret server node in my home lab can run the OpenBOW workload, but only if it's running as a systemd service on that node. So it's like you can declaratively describe the different workloads on all your machines, and then Spire takes care of issuing certificates for all of them and injecting them. And so, for example, we also have a workload for Prometheus Node Exporter, and just every node in our cluster which runs Prometheus Node Exporter.service can get a certificate for it. And yeah, then all we need to do is, before a systemd server starts up, we fetch the certificate from Spire. And we need to then configure our services to use the X509 certificates that Spire gives us. And we have to do this for every service. So for Prometheus, for Alert Manager, for Node Exporter. And we also configure OpenBOW, like, hey, if you connect to OpenBOW with TLS, and you are the Alert Manager workload, oh, then you can read the webhook secret. So yeah, all our problems are mostly solved with a lot of extra code, but Prometheus can talk to the node exporters over MTLS. Prometheus talks to Alert Manager over MTLS. Alert Manager can authenticate to OpenBOW using TLS and fetch the webhook secret, and Alert Manager can now send alerts to my phone over the webhook. But I wanted to do more. HTTP challenge is kind of a weak bottom turtle. Like anybody in my home lab can just reply to a DNS record and say, I am the secret server, give me a certificate for OpenBOW. And then I thought, okay, all my machines have TPMs, why don't I use the TPMs on my machines to authenticate? So I wrote an attestation plugin for Spire, which every TPM comes with a unique key baked in by the manufacturer called the endorsement key. And you can do some elaborate dance to figure out whether this endorsement key is genuine and by the TPM manufacturer that you expect. And then we can use that as the node identity of the nodes in our cluster. So when a node joins the Spire server, like the node authenticates to the Spire server, it will say like, okay, I'm this TPM with this endorsement key by this manufacturer, and these are the PCRs that I measured. So we can now use this endorsement key as the identity of our node. So I can configure now my NixOS machines to use this plugin. And then they can authenticate using their endorsement key and prove their identity. But we want to connect this to the workload identity, like what is the workload that's actually running on these machines, right? And yeah, there's some cool things that systemd gives us here. They have all these toolings for building images like ukify, systemd-repart, makeOSI. And one of the cool things is that when you build an image with these tools, you can predict the PCR values that get measured into your TPM during build time. And that's, so we'll get a different PCR value if we load the OpenBow disk image versus the alert manager disk image versus the Prometheus disk image. And we can use that as a very strong, unique identity for each of the nodes. So we can say only the OpenBow disk image can get the OpenBow certificate, and the alert manager disk image cannot get the OpenBow certificate. And this is really easy to do with NixOS, thanks to this person in the front. So we have a repart module that you can use to build repart images. And you just say like, okay, Verity store enable true, which puts the entire Nix image in a Verity container, puts the hash of the Verity container in the kernel command line so that it authenticates the disk. And that all gets packaged up in a UKI. And then when systemd loads the UKI, it measures the kernel command line and does also the entire contents of the disk image. And then we can say, okay, a certain node in my home lab is only the identity that we expect it to be if it matches the PCR11 hash that we predicted during build time. And with that, we have like an entire cluster that we can boot up without having any secrets. All these things are public. Like we can calculate the hashes of our disk images. We can pre-calculate the PCRs. And from that, everything in my home lab can start talking to each other over TLS. At least that's the idea. Yeah, so now it's the time for the mother of all live demos. This is a terrible idea, but I'm going to do it anyway. Let me switch my screen to mirror. So yeah, here I have a NixOS test where I've loaded in all the code from all the slides. And then and what this does is it will create a QEMU VM for every NixOS node definition. And then we have some Python with which we can start up the QEMU VMs and like write assertions. So we're going to start up our Spire server, our OpenBow server, bootstrap OpenBow, put in the secret in OpenBow, and start up the alert manager and Prometheus. Whilst I run through this, just run it. And then in theory, they should all start up and be able to authenticate with each other. And we should get a browser opening after this build. It's going to take a few seconds. Drum roll. Okay, so it's going to spawn a whole bunch of QEMU VMs, booting all these images that I built. And then each of the QEMU VMs is going to use their virtual TPM to talk to the Spire server and authenticate. And then, if everything works, in a few seconds, a browser window should show up with Prometheus showing all the endpoints. But let's see if that actually works. So now Alert Manager starts up. Ignore the errors. There's a retry. There's a retry. I fixed that. So okay, it retried and now works. And okay, now Prometheus starts up. If this works in one go, I'm going to be very happy. But and okay, yes, okay. So I don't have internet, so I cannot visit the webhook website, but I can visit Prometheus. Okay, so the media server is not up, that's on purpose. But you can see it's scraping all the Prometheus node exporter endpoints over TLS. Everything is up and running. And we have alerts which should start firing because one server is not up. And then here we have Alert Manager running, and we can also see the certificate. If you go to details, that it's indeed the certificate that we expect. So we have here, it's indeed homelab.internal/workload/alert manager that's running this. And then, yay, an alert came in that my media server is down. And if I had internet, then we would have seen the alert come to my phone here. But yeah, that's my completely over-engineered homelab bootstrapping itself with TPMs and talking to each other with TLS. And yeah, that's what I wanted to show. And are there any questions or thoughts?
Yes. Yeah, so first of all, I want to congratulate on this, because that's something that I wanted to do for years, and I always lacked basically the last hurdle. But now that I learned about SPIFFE and Spire, I think I'm going to work on completing this. But to make it easier, now that you don't have to publish your secret webhook URLs anymore, do you have all this online and somehow documented a bit?
It's not published yet, but I'm planning to publish this like today or tomorrow. It's yeah.
Thank you.
Thanks for an interesting talk. How does the enrollment story of new nodes look like? Let's say you buy another physical node in your home lab, or
yeah. So currently, I just wait. Let me. I just say any node that comes up with a TPM that is from a manufacturer that I trust is fine. But yeah, but a TPM doesn't identify your computer, right? It identifies the TPM. So that's currently like a simplification I made. Like if a TPM is genuine, you can enroll into my home lab. But I want to, in the future, also start measuring PCR15, which contains like the machine ID of my machines, so that if each machine is not only identified by the TPM that's on the motherboard that you could move to another machine, but also by like the actual root disk with the machine ID that you expect. But that's future work. For now, it's just any TPM that's genuine can join my home lab, but they will not get their workload identity, right? Because they will not boot. Well, unless somebody goes into my home lab and boots the same image that I boot, but that just means they gave me free hardware. So I'm like, okay, that's good. Yeah.
So are you just relying on PCR 11 measurements or also something like PCR 4 and 7 in addition to that?
At the moment, only PCR 11.
Because then couldn't an attacker, like if they also modify the stub, since that's in control of what goes into 11, you could kind of spoof it that way, right?
Yes. So future work is to, for the VMs it's very easy because I just can record the 4 and 5 and 7 and just record them and keep them around, right? So I want to do it, but I haven't yet. So just PCR 11 for now, yeah.
More questions? No more questions?
Thanks for basically doing what I did yesterday, except for I just used Acme from Bao itself. So how do you go about hosting providers? And I mean, these VMs usually do not have a TPM. Do you use software TPM or just the Acme challenge?
So this is all running in my home lab, and they have TPMs. If your hosting provider does not already have workload identity, like I don't know, GCP or AWS, but you're at Hetzner, then I would just use the HTTP challenge as like a easy way to bootstrap stuff. Yeah. Like it's not perfect, but it's better than nothing. Yeah.
By the way, you do know that OpenBAO also has an Acme server?
Yes, I know. But what OpenBAO does not do is the workload identity API, where I can just talk to a workload, like to the socket over Unix domain sockets, and it just figures out, oh, it's this systemd service, you can have this credential, right? This is something that's OpenBAO doesn't do. But yeah, so that's why I think Spire is kind of nice. And
indeed, thanks for the talk.
Yeah.
Okay, we're out of time. Thank you very much, and thanks again.